Welcome back. We'll do the lift again. We'll continue with the lift from wherever we have stopped in the last class, last half an hour slot. So, we follow it up, right. So, lifts, that is what we were doing last time, and then we remember, if you recall, that we talked of round trip time as sum of A, B, C, D, E, 5 components. I will not repeat this too much now, but only thing that I want to highlight here today, because we have done it last class itself, highlight today is that we got to know two things, S and H. What is S? S is the probable number of stops and H is the probable height of reversal, expected height of reversal. That is what we said in the last class, right. And this we can determine basically heuristically, that means by just simple logical thinking, or from the concepts of assuming process of people boarding in the lift as and boarding in the lift is an waiting situation with Poisson's process, assuming it to be a Poisson's process, waiting for the lift, and then lift serves the people, So, as if people are the customer, lift is the service provider, then the person enters and disembarks somewhere. So, this can be thought of as a waiting situation, waiting line situation, but then we are not going to do that today. We will look into how do you determine S and H heuristically, that means by thinking process. Of course, the probability comes into picture. So, that is what we can do. So, to do that, let us now look at, first of all, let me first to try to find out the probable number of stops, probable number of stops, that is S, right. Let me find out probable number of stops, that is S, right. Now, how do I find out S? What actually it would be? People, because we said it is a one way traffic, upgoing traffic only, we are designing the system for upgoing traffic only, and we have q number of people boarding, right, q which is actually 80% of the capacity, which is actually 80% of 80% of capacity, lift capacity. So, it runs at q number of people boarding the lift car, and then they disembark in between wherever they are supposed to go. So, we are looking at the upgoing traffic only, because as you remember, in the round trip time and the design of the lift system we pick 5 minutes time for single purpose office, which is the most crucial, and that is how we do the lift design. This concept can be extended to anywhere else, right. So, because this is most crucial. So, we said that q people would be boarding the lift and they will disembark. So, if I if I know the population of each floor, let us say population of first floor is P 1, right, population of first floor, P 2 is the population of second floor, and so on, and P I is the population of ith floor, P I is a population of ith floor, P I is a population of ith floor, right, P I population of ith floor, I mean let me use keep it capital P only, population of ith floor we are trying to find out S. Then probability of finding a person belonging to ith floor will be given by P I divided by sigma P I going from 1 to n, where n is a lift serves n number of floors. So, lift serves n floors. So, probability of finding a person and population in first floor is P 1, second floor is P 2, third floor is P 3, etcetera, and P I is the population in ith floor. If I sum up for all the floors, that will give me the total population to be served for nth floor. So, probability of person boarding the lift and belonging to ith floor is P I by sum of all P i's, I going from 1 to n, right. And if that if so, therefore, probability of finding a person in ith floor is given by this, and I am interested in finding out probability of finding at least one person in the ith floor out of all the q people who have boarded, out of all the q people who have boarded. So, at least one person, right, not all the persons, at least one person must be in ith floor, then ith floor will be the stop. So, I am interested in finding out at least one person. So, P I minus divided by sigma P I 1 minus that is probability of not finding a person in ith floor. Okay. Probability of not finding a person in ith floor. So, let us look at it again, right. Probability of this is what I am looking at, this is what I am looking at, probability of finding S is what I am looking at. So, we have seen P I divided by sigma P I is the probability of finding I going from 1 to n, probability of finding one person, probability of finding a person out of Q belonging to ith floor. 1 minus that is probability of not finding a person, right, in ith floor, and 1 minus that is the probability of finding at least one person. Now, what I can do is, this is, since I am dealing with q persons, this is the probability of not finding a person in ith floor. Probability of not finding the second person, 2 persons, will be simply multiplied, because this is joint probability and they are independent persons, this independent event, they being there, one person being there, second person being there. So, it is simply joint probability 1 by P I divided by sigma P I, again I going from 1 to n. So, I will not write that again, and this for the q terms, that is joint probability of not finding any one of those q persons, joint probability of not finding any one of these q persons belonging to joint probability of not finding any one of these q persons belonging to ith floor, this product. So, this is the term actually, if you look at it, this is the term, right, this is the term, this term 1 minus P I, I mean only I am just writing 1 minus P I divided by P to the power q is the joint probability of not finding any one of this q person belonging to ith floor, and 1 minus that gives me probability of finding at least one person. You see, probability of not finding any person, and 1 minus that gives you probability of finding at least one person, right, which means that ith floor will be the floor of reversal. So, probability of finding a person in ith floor, 1 minus that gives me probability of not finding a person in ith floor, to the power q gives you all the q people who have boarded, not finding any one of them in ith floor, 1 minus that gives me probability of finding at least one person, right. 1 minus that gives me at least one person will belong to, out of those q will belong to ith floor. This multiplied by 1 is the expected ith floor being a stop. This is multiplied by 1 is so expected value of ith floor being the stops, and this I repeat for all the floors. That means, I sum up for next floor 1 minus 1 minus p I plus 1 divided by p, this to the power whole thing to the power q, whole thing to the power q, not this bracket is not there. This is the probability of 2 floors being expected number of floors, and if I repeat this for all n floors, that gives me the value of S, that gives me the value of S. If I repeat this for all floors, that gives me the value of S. So, let me just explain again. This is the probability of finding a person in P is the total population, which is P is equals to sigma p I, I going from 1 to n for all floors. So, probability of finding a person in ith floor. 1 minus that is probability of not finding one person in ith floor. Probability of all q persons not belonging to ith floor is this, and this 1 minus this term alone, not the sigma, 1 minus this right, 1 minus p I by p to the power q, that is the probability of finding at least one person in a given floor. When I sum it up for all n floors multiplied by 1, I get n here, because summing up and the n sum up comes here. So, that is the probable number of stops, 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 right. Now, this is when populations are different. If populations are same in all the floors, in population in all the floors are same, then p I by p will be simply 1 by n, because this would be simply sigma p I going from 1 to n, and since this value is constant equal population. So, let me whatever the value is, it will be simply n into p I, or so p i's will cancel out. So, when population is same, the formula becomes a little bit simpler, S then becomes n minus simply I going from 1 to n, 1 minus 1 by n to the power q, where population in all the floors are same, which is generally may be the case, because floor areas are same, and if it is a single purpose office, occupancy is the same type. Therefore, we know the population is actually, we can estimate the population some x x meters, x persons per meter square, x person per meter square. For example, for residential it was 12 or 12.5 or such something similar to that, 12 meter square per person. For office it will be much less depending upon type of office. So, if the floor area is same of the every floor, then I am likely to find population being same, then I can use this simpler formula S, that is probable number of stops, right. So, probable number of stops. So, this is one part. I need still one more thing, that is my expected height of reversal or probable height of reversal. Similar logic will apply, similar heuristic logic we apply, similar heuristic logic will apply. Let us see what is the logic do we apply. You see, first thing is I got to look into probable say jth floor being the probable floor of reversal. Now, when will it happen? When I have at least one person, I mean they might go anywhere down below, but at least one person going to jth floor, but nobody above, right. So, finding at least one person going to jth floor and nobody above. Now, finding one person up to jth floor would depend upon probability of, I can find out like this, supposing jth floor. So, probability of finding a person up to jth floor. So, it would be P 1 plus P 2 plus P 3 P j divided by P j divided by P sum of P i's I going from 1 to n. This is the probability of finding person in any one of these floor 1 to j, right. Probability of finding any person up to jth floor, and if I do it for all q of them, the probability of finding all q persons belonging to up to jth floor. But if jth floor has to be the floor of reversal, then I must find probability of finding a person in jth floor itself, which will be simply P 1 P 2 up to j minus P j minus 1 divided by P to the power q. This will give me the probability of finding a person only up to one floor below, and this difference gives me the probability of finding the people q people who have boarded one person belonging to jth floor. So, probability of finding people who are boarded all probability of finding all people belonging to jth floor minus out of those that at least one person is there in the jth floor and rest all might be j minus 1th floor. So, I subtract this. This is the probability of height of jth floor being height of reversal, right. So, this multiplied by j gives me the jth expected value for jth floor. Remember expected value is nothing but the value of the random variable itself multiplied by the probability. So, we are trying to find out the probability of jth floor being the height of reversal, exact probability of jth floor being the height of reversal, and multiplied by j and sum it up for all of them, all the floors, then I will get the h, then I will get height of reversal. So, let us see this, let us simply see this. You see the expected floor of reversal. So, it says that I find out the probability of P 1 first floor being population up to first floor minus probability of finding this population one floor below, and that is probability of first floor being the floor of reversal, probability of second floor being the floor of reversal. I am not considering anything above, because I am assuming all the population up to this floor and 1 minus 1 floor below. So, that multiplied by 2, because second floor, third P 3 and n minus 1 and n P n, last one, this is the last one, right. So, n P n, and this value will be 1, P n would be 1, because it will be sum total of P 1 P 2 P 3 up to P n divided by again P 1 P 2 P 3 etc. So, this value will be actually 1, if you remember, because we said that P P n up to P n is P 1 plus P 2 plus P 3 up to P n, and this is also sigma P I, which is nothing but P 1 plus P 2. So, this value will be equals to 1. So, it is simply n, right. So, this value is 1, this is simply n, okay, or right. So, let us look at that. So, we can actually come to, right, okay, we will come to that later on. So, now let us P 1 I have explained to you, I have explained to you P 1 P 2. What is P 1? Population up to P to the power q minus 0, because that can be ground floor multiplied by 1. This is population up to P 1 plus P 2 divided by P minus P 1 by P to the power q into 2, and similarly for all this sum. Now, interestingly, if you see in this sum, you will see something, P 1 by P comes here and it is there in the next term also, right, next term also, but here it is negative and multiplied by a factor 2, here it was multiplied by 1. If you look at this, this is multiplied by 2 and here it is multiplied by 3, but with a negative sign, right. And in the last term, if you see it, this is a positive term, this is the this is the positive term n into 1, n into 1, because it will not get cancelled in the next one, there is nothing above n. So, this is the term which remains, which is n, which is simply n into 1. So, this remains. Rest all you will have one term each cases there is a negative term, because this is twice of this, here thrice of this with a negative term. So, what I find is, what I will find it, I mean if I take the jth term, then I will get again the sum going from I going from j p I divided by p to the power q, and this going from I going from 1 to j minus 1, you know. So, this is going j minus 1, for example this was 2, this was j minus 1, j equals to 2, this is 1, j equals to 3, this is 2, and so on. So, this is generalized term, this is a general term. General term will look like, which I just explained a couple of minutes earlier, sigma p I going from 1 to j, right, divided by p to the power q minus sigma p I going from 1 to j minus 1 divided by p, which is sum of p I, you know, which is sum of p I, right, to the power q, into j is the intermediate term, any term, and last term would be something like this, right. So, that is what we see. So, there is one negative term remaining from everywhere, and if I collate this negative terms, if I collate all those negative terms, I get something like this. This I get 1, every, you know, I will get 1 only, because 3 minus 2 is 1, 4 minus 3 is 1. So, I get a negative term, here I get another negative term of this, and so on, you know. So, I minus 1 going to j minus 1 and p. Last term will be simply p I divided by p sum, you know, so last term will be simply n into this p by p to the power q. So, then if I do a little bit of algebra out of this, if I do a little bit of algebra out of this, right, if I do a little bit of algebra out of this, what do I get? If I do a little bit of algebra out of this, I will get, you know, I will get, if I do a little bit of algebra from this, I will get h equals to, sum this up, this last term comes as n, all other terms, because there is only one term remaining. So, it will come as, you know, j going from 1 to n minus 1, right, because j going from 1 to n minus 1, the internal sum is this, there is an internal sum which is p 1, p 2, p 3 up to j divided by p, and this is summed up now. So, this all these are summed up, you know, there were sums were like this, I had something, if I may write it like this, minus sign is very much there, p 1 by p to the power q, p capital P is nothing but sigma p I. So, I am just, you know, I going from 1 to n total population. So, this is the first term, next term will be p 1 plus p 2 divided by p again to the power q, and p 1 plus p 2 plus p 3 divided by q, which in other words my j will be going from 1, 2, 3, you know, j would go. So, there is a j going from 1, 2, 3 etcetera, etcetera. So, there is a summation from I going 1 to j, and j goes from 1 to n minus 1. So, this term I just, each term, you know, I can just overall sum it up. So, this if I sum it up, internal one, this will write it simply, it is going from I going from, you know, p I going from 1 to j, right, and 1 to j divided by q to, you know, divided by p to the power q divided by p to the power q, right, that is what is coming. So, to the power q. So, I to j it is going, and then j goes to 1 to n minus 1. So, for j equals to 1, first term j equals to 1, it is this term, j equals to 2, it will be only this term, j equals to 3, it will be this term, j equals to 4, it will be this term. So, whole thing can be now written in a compact manner we can write in this manner. So, this is the expected height of reversal, because we have multiplied by the floor number, multiplied by the probability of that floor being the height of reversal, and so on. So, this is the expected height of reversal. So, this is how we find out the expected height of reversal. Now, if the population are same, this will be simply written as j into p I, you know, this will be simply written as n minus sigma j going from 1 to n minus 1, and within bracket this will be simply j into p I and divided by n p I. So, p i's will cancel out, I will be left with j by n. So, this will become, you know, this sum will become j going from, simply it will become, you know, it will get simplified, I will write it like this. So, for all population being same, I will simply write this term as j by n, and j going from 1 to n minus 1, j going from 1 minus 1 to n minus 1. In other words, let me just rewrite it. So, for population being same, this would be n minus some j going from 1 to n minus 1, and inside is j by n, j by n. So, this is how it this simply simplifies to a simple thing, height of reversal. Now, having done that, now I know h and s, and therefore, I can calculate out the round trip time. I can calculate out round trip time, right. Round trip time I can calculate out if I go back my earlier slide. If I go back to my earlier slide, so h known, s is known, I can calculate out round trip time. Best of course, is an example calculation. So, let us see that example calculation. Let us see the example calculation. There is an example calculation I have. So, this is how we define, we find out s and h. This is how we find out s and h, height of reversal and s. Heuristically, of course, one can find them out probabilistically more, with Poisson's process, achieving process. We will discuss sometime later on. And now, let us look at the example calculation. So, example calculation is something like this. Consider 16 floors, total population 1000 for simplicity, car capacity is 16, right, car capacity is 16, door closing time is 2.5 seconds, door opening time is 1.5 seconds, and height, constant speed time Tb, remember we talked of Tb earlier, at constant velocity every floor would be jumped, is called one floor jump time is 1 second, and person entering is 1.2, person getting unloaded, loading and unloading 1.2, and one floor jump time is 5 seconds. Now, what is one floor jump time? I think I have explained it earlier. One floor jump time is you start from a floor, it accelerates, goes to the constant speed and then stops. So, it has got an acceleration and deceleration and of course, a little bit of constant speed in between. So, that is the jump time, and we have explained this earlier. Now, let us see next. So, q is 80% of 16, 0.8 of 16, 0.8 of 16, which is 12.8, right. And h therefore, since we are assuming equal population all over the place, all floors. So, simply I by n to the power q. So, 16 minus sigma 1 by 16 plus 2 by 16, 3 by 16 up to 15 by 16. So, if I sum this up, I get 15.3. S same formula, because I said that when it is all equal, then I get something like this, that comes out to be 9, right. You can check this calculation. So, n is equals to 16, 1 minus 1 minus 1 by 16 to the power q, that is your 12.8 comes out to be 9, and T s is the sum time, that is what we said is a 5 seconds, this T f plus 1.5 second opening time and door closing time, and minus 1 constant speed one floor jump time, that is your T s. So, R T T therefore, by putting in the formula that we talked about A plus B plus C plus D, A B C D etcetera, if I put it and I get 141.3, that is the round trip time for a lift, right. And if I have 5 lifts, then my waiting interval becomes 141 divided by 5, which is 28.3 seconds, 28.3 seconds. Therefore, handling capacity I can find out. Remember, handling capacity was 300 into the capacity q into 100 for percentage into divided by waiting interval, and total population is here. So, we express it in terms of percentage of population, that comes out to be 13.6. So, that is how we actually find out the handling capacity. Now, what we will do is we will this is how we find out the handling capacity, this is how we find out the handling capacity, right. So, this is how we find out the handling capacity. So, what we will do is next time we will look into, but this one thing we have assumed. We assume the arrival of the people and their service, the rate is same. The rate at which, for example, every every 5 minutes people coming, or every 1 minute number of people coming, all of them are being served. In every 28.3 seconds or whatever it is, there is a lift. So, whatever people come in 28.3 seconds, all of them will board, and they are equal to 12.8 or some on an average, something of that kind, right. So, this is an assumption made. Without this assumption also we will be able to calculate out, we will see that later on. So, I think we will have a break, right, and after that we will follow up with the next lecture, right. Okay then. So, that is it. So, thanks for time being. I will take some question from the students here.